All right, Unit 9, Day 2, Solving Systems by Substitution. All right, now on Day 1, remember, we started solving these systems by graphing. Remember that a system is just either two equations or two lines on the graph. To solve a system, you're just trying to figure out what order pair satisfies both of those equations, or where those two lines cross. Now, graphing always works, but there are other ways to solve a system that don't require a graph. And the first one we're going to talk about is substitution. The best way to remember how to do substitution is through the use of an acronym. And that acronym is ISS. Okay, now this is not in-school suspension, so some of you guys who are getting kind of nervous, y'all can calm down. What this stands for is isolate, sub, and solve. Isolate, sub, and solve. Now, what I mean by isolate is that you're going to try to get one of your variables by themselves. So you're going to be looking for something like an x equals or a y equals in one of your two equations. In other words, you're going to try to have one of those variables isolated or by themselves. After you do that, then you'll eventually sub in whatever those variables equal into the other equation and begin to solve for your missing value. Let's do a couple of examples so I can show you what I'm talking about. Take a look at number 1. You have 3x plus 2y equals 27, and y equals 3x. As you look at those two equations, you want to look for which equation, the blue or the red here, which equation already has a variable isolated. Well, if you look at the one on the bottom, the red one, it says that y equals 3x. So that 3x, that is what y equals. And if that's true, then we should be able to go up to the other equation where there's a y, pluck that y out, throw it away, and replace it with that 3x. So when I rewrite this here in a moment, you'll see what I'm talking about. The blue one is 3x plus 2y equals 27. But when I get done subbing in what y equals, it's going to replace that y with 3x. So we made an even swap. Now what we can do is, since we only have one variable in our equation, x, we can solve for x. Okay. On this left side, we have 2 times 3x. Well, that gives us 6x. Okay. On that left side, we still have like terms here to simplify. 3x plus 6x is 9x. That equals 27. When you divide both of those sides by 9, you get x is equal to 3. Okay. That gives us one part of the order pair that we're looking for. So remember, we're looking for the point where those two lines are going to cross. We know that x needs to be 3. Well, to figure out what the other one is, well, you sub and solve again. If you go back to your isolated equation, your y equals 3x, if you know that y equals 3x, and you just found out that x is 3, well, you can replace that x with 3 and figure out what y is. Well, 3 times 3 is 9. Y equals 9. What this tells us without the use of a graph is where these two lines will cross. They will cross at the point 3, 9. Just like with the graphing, you can check this answer. And yes, I will require you to do so. So take a look at your first original equation there, the 3x plus 2y equals 27. And let's plug in our values and see whether or not they actually check out. We think that x is 3 and that y is 9. Let's see what we got. 3 times 3 is 9. 2 times 9 is 18. The sum of those two numbers is 27. Our first check is successful. Let's take a look at the next one. Y equals 3x. Plug in a 9 for y. Plug in a 3 for x. 9 equals 9. We're looking good. That lets us know that 3, 9 is the correct answer. That is the point where those two lines are going to cross. Okay, let's take a look at our second example. As we look at the blue and the red equation on our second example, the one on the top, the blue one, there's the isolated variable. This time it's x. It doesn't matter, but it tells us that x equals 9y plus 9. Well, if that's what x equals, if x equals 9y plus 9, then we should be able to go to the other equation, wherever x is, pluck that x out, throw it away, and replace it with that 9y plus 9. Let's see what I'm talking about here. Okay, there's where the x was. Now it is replaced with 9y plus 9. Then I'm going to go ahead and copy down the rest of that red equation. There's still the plus y there and the equals to negative 20. None of the equation changed except for where the x was. All right, now in order to solve for this y, because now the only variable left is y, we need to make sure that entire left side of that equation is simplified. It'll mean that we're going to have to do a little distributive property, and then eventually we're going to have to combine our y's and eventually solve for y to see what it equals. Okay. 18y plus 18 plus y equals negative 20. On this left side, we have 18y plus that other y. That's 1y. So when we add those two guys together, we get 19y. Okay. Now let's begin to solve. We'll subtract away our 18. That gives us negative 38. They're both going in that negative direction. Divide away your 19, and y will equal negative 2. Okay, that gives us half of what we need. We think that the y value will be negative 2. What we now have to find is what the x value is. Okay, so we go up to our isolated equation where x equals 9y plus 9. We found with our equation that we think y is negative 2. So let's replace that y with negative 2. So here we are subbing and solving again. Now to figure out what x is, we just do a little bit of multiplication, a little bit of addition. 9 times negative 2 is negative 18. When you add the 9, you get a little tug of war, and the negative 9 wins. Okay? We end up with the order pair, negative 9, negative 2. Okay. We could verify that with a graph if we wanted to, but we've already done it with substitution. Let's just do our check and see if this works out. Okay. Let's see what we got here. All right, plug in the negative 9 for x. Plug in the negative 2 for y. This does look familiar, I know. There we go. The first one checks out. Let's try the second one. 2x plus y equals negative 20. Let's replace the x with negative 9 and the y with negative 2. And we end up with negative 18 plus a negative 2 equals negative 20. Both the 18 and the 2 are pulling in that negative direction. They're going to be equal to negative 20. That one checks out. That lets us know that negative 9, negative 2 is the correct value, the correct solution to that system. Okay, let's try one of these on your own. Come down here to the blank space there on number 3. And let me give you this one. Let's see how you guys do. It says that y equals negative x minus 3. And then the bottom equation is 3x plus 2y equals negative 3. All right, get as far as you can on your own. So pause the video, see if you can get all the way to the solution. See if you can go through the check. And if you get stuck, unpause the video, and let me see if I can help you out. All right, go for it. All right, this is what y equals. So I'm going to replace that y in the red equation with that blue negative x minus 3. Okay. All right. In order to finally get x by itself so we can solve for it, we're going to have to simplify that left side. So we're going to do a little multiplication there with the distributive property. Let's see what we get. 2 times negative x, that's like negative 1x, so that's a negative 2x. 2 times a minus 3 is minus 6. We have like terms here on that left side, 3x and negative 2x. When we add those guys together, we'll just get 1x. Then we can now begin to solve. This is just a one-stepper. Add away your 6. And tug of war there, the x will win, sorry, the 6 will win by 3. Okay. So that's half of the order pair we need so far. Now, take that x equals a 3. Go back up to your blue equation. Plug that 3 in for x, and let's see what you get for y. Okay. This says that y equals the opposite of 3 minus 3. Okay, well, the opposite of 3 is just negative 3. So we end up with negative 3 minus 3. Notice that both of those 3's are going in the negative direction. You're going to end up at negative 6. Okay, that's what we think the solution to that system is. Let's check it with our two equations. Okay, plug in a negative 6 for y. Plug in a 3 for x. All right, negative 3 minus 3 is negative 6. The first one checks out. Let's try the second one. All right, let's plug in a 3 for x. Plug in a negative 6 for y. 3 times 3 is 9. 2 times negative 6 is negative 12. The tug of war there has the negative 12 winning by 3. Okay, that one checks out. That is the correct solution to our system. Okay, a couple more examples I want to talk about, then I'll leave you guys alone. Come down here to Roman numeral 2 with special systems. Okay, these are going to be ones where as we begin to work them, something weird is going to happen. We're not going to be able to finish the problem. So let me kind of explain what I'm talking about. On the number 5 here, or I guess number 4 is what it should be. You have the blue equation. It tells you what y equals. There's your isolated variable. I'm going to take that 3x plus 5. I'm going to come down there and replace that y with that. So we end up with negative 6 plus 2. Okay. And then I'm going to plug in my 3x plus 5. Now on this left side, it's going to require a little bit of distributive property. And then I'll combine my like terms and eventually start to solve. We'll see what I get here. Okay. On my left side, I still have like terms. So before I can solve it, I'm going to make sure that that left side is completely simplified. Negative 6x plus 6x. Now, what happens here? The x's are going to cancel out. How many x's do we have left over? None. They go away. All we have left over is 10 equals 10. Okay, so what gives, right? The equations are trying to tell you something. They're telling you that this is a special system. And they're telling you that you have a special type of answer. The remaining sentence that's left over here, the remaining equation, this 10 equals 10, if it is true, if 10 does in fact equal 10, which it does, this is true, it's trying to tell you that these are the same two lines, that these guys will lay right on top of each other, just like we did with graphing. They'll have infinite number of points that they touch. This one is infinite solutions. So think about your word connotation there. A true statement means infinite. True is infinite. Okay? Let's take a look at the next one. On the next one, the bottom there, the red, don't be afraid of these fractions. We'll be okay. We'll replace that x on top with that negative 3 halves x plus 12. All right, let's see what we got here. 3y equals negative 2 times all that junk minus 12. Okay, let's put all that junk in there. All right. On this right side, we got to make sure that everything is simplified before we move on. A little distributive property there, and eventually we'll combine our like terms. All right, so 3y equals, let's see, negative 2 times 3 over 2. Remember, just put the negative 2 over 1. On the top, we're going to get negative 6. On the bottom, we get 1 times 2 is 2. Negative 6 divided by 2 is negative 3, so we have minus 3x. Okay. This should be a y. Excuse me there. Something's not working right. Okay, found my goof. This right here is a negative 3 halves y, which means that should be a negative, which means that's going to be a positive 6. So what we really have here is not a negative 3y, but a positive 3y. Okay, I'm back in business. With my distributive property there, the negative 2 times 12, that's minus 24. Then we get that minus 12 at the end. Let's see, I had to combine some like terms here, negative 24 and negative 12. I get 3y equals 3y minus 36. Now, in order to solve this, I got to get all my y's on the same side, right? This is where we had to collect our variables. So let's say I want to get all my variables over on the left. Well, that means I'm going to subtract my 3y from both sides. Okay, what's going to happen here? On both sides, your variables get canceled out. On the left side, you end up with 0. On the right side, you end up with 0 minus 36, which is just negative 36. So here's another example where our variables go away. So what does this mean? Well, this means we have a special solution. But look down at the bottom there and see what type of equation do we have here. Do we have a true statement or a false statement? Well, what we have is a false statement. These guys are not equal to one another. So what it's trying to tell us here, use your word connotation here, false would mean no solutions. Okay. Sorry about the hiccup there, you guys. Thanks for staying with me. Now, make sure that you guys have finished the homework on the first page of this. The 2 graphing on the top, and then, of course, the 3 word problems. Look forward to seeing you guys in class soon. Stay golden.